Hello, it's Mr. Luneski. Today we are looking at the start of Unit 5. Unit 5 is all about triangles. How exciting. Unit 5, Section 1. Today we're going to be looking at the different types of triangles and something very important called the triangle sum theorem. So let's get started. So we have some vocab words that we've heard of before, some things that we've seen. There are two ways to classify a triangle. The first way is to classify it by its angle. So every triangle kind of has two names, like a first and a last name. So one of the names is classifying it by its angles, and the other name is classifying it by its side lengths. So we're classifying it by the angles of a triangle. So the first way to classify a triangle is we could call it an acute triangle, and it's acute if all three angles of the triangle are less than 90 degrees. So that may look, I don't know, something like that, where all of these angles are less than 90 degrees. An obtuse triangle is when we have one angle that is greater than 90 degrees. So that may look something like this. A right triangle, hopefully you know this one. A right triangle is when we have one angle that is equal to 90 degrees. And so remember that we can't just assume that that's 90 degrees, that we have to mark that it's 90. So if you don't see that little box in there, you cannot make any assumptions that, that looks 90 degrees. And then finally, a word that you may not have heard is equiangular. Equiangular means that all of the angles are equal. And kind of the unique thing about a triangle is that if all of these angles are equal to each other, all of these angles end up equaling 60 degrees. And we'll get to that in a moment. So those are the four ways to classify a triangle by its angles. There are three ways to classify triangles by their side lengths. So not really looking at the angles, just looking at the different side lengths of the triangles. So the first way is equilateral. So equilateral, equa meaning equal and lateral meaning side, is telling us that all of the sides of the triangle are congruent, meaning that they have the same length. Little fun fact here is that if a triangle is equilateral, we can then say it's equiangular. So I wrote this as a biconditional statement, a little throwback for you. A triangle is equilateral if and only if it's equiangular. So those two things always go together. So if I ask you to classify a triangle, if you're like, hey, all those sides are the same, then you can say it's equilateral and equiangular. So they always go together, equilateral, equiangular. Can't have it any other way. Isosceles triangles are when two of the sides are congruent. And so that typically looks maybe something like this. And remember that these little marks here indicate sides are being congruent. So we're going to see a lot of these marks in this next unit. And then the last one is a scalene triangle. A scalene triangle is when none of the sides are congruent. So that may look something, I don't know, like that. So none of those sides are equal to each other. So those are the ways of classifying triangles. So now we're going to take a look at some little parts of triangles, some theorems that we can pull from this. So we have what's called the base angle theorem. And it says if two sides of a triangle are congruent, in other words, if it's isosceles, if the triangle is isosceles, then the angles that are opposite them are going to be congruent. So we're going to have two sides in a triangle that are congruent, so that may look something like this, like I showed earlier. And what this is saying is that the angles that are opposite these sides are going to also be congruent. So these sides here, the opposite angle is this one and this one. So when it says opposite, that means the one that I can kind of draw a line across to. So like just extend that line out, whatever angle it touches. So these two angles here would also be congruent. Those two angles are referred to as the base angles. The converse to the base angle theorem, converse, remember, PQ, QP, Converse is saying if two angles of a triangle are congruent, then the sides opposite them are congruent. So for instance, if I had a triangle, and let's say that this angle was congruent to this angle, I would be able to say then that the sides opposite these angles, this side here and this side here, that these two sides would be congruent. That's the converse to the base angle theorem. So here's an example of kind of where we would see something like that. It says, find the measures of the sides of isosceles triangle KLM with angle K congruent to angle L. So we know that this angle here is congruent to this angle here. And so now we're going to use that base angle theorem, or the converse of the base angle theorem, to figure out which of these two sides to set equal to each other. So based on this, I know that this side here and this side here are going to be congruent, or equal to each other. So now to solve for this, I'm going to set those two expressions equal to each other. And now we're going to solve for the variable. So we're going to add d to both sides, subtract 13 from both sides, and then divide by 5, and we get d is equal to 5. So now here's where we need to be careful. It says find the measure of the sides. So we didn't just want to solve for the variable. Now we actually have to substitute 5 back in to all of these expressions. So if d is 5, 5 plus 6, that's equal to 11. 12 minus 5, that's equal to 7. And if everything went well, we know that this should also equal 7, because we said that these two sides were congruent. So 4 times 5 is 20. 20 minus 13 is also 7. So those are my side lengths. Okay, the next one, it says find x in the measure of each side, so we need to remember to substitute x back in, of equilateral triangle ABC. So here, notice we don't have a diagram, so I think it's always helpful to draw a diagram. Now, how did I label that ABC? It really doesn't matter. Kind of can put those wherever. You can put A here and B here. Realistically, it doesn't matter. So now we can label our sides. AB is equal to 6x minus 8. BC is equal to 7 plus x. AC is equal to 13 minus x. So now this is saying this is an equilateral triangle. Equilateral means that all three of these things are equal. So here's where you actually have some freedom to kind of do whatever you want with this one. There are essentially 3 different things we can set up. We can set up that AB is equal to BC. We can set up that AB is equal to AC. Or we can set up that BC is equal to AC. Any of those work, because all of the triangles or all the sides are the same. So I'm just going to pick, I don't know, these two. And we'll say that 7 plus x is equal to 13 minus x. And now I'm just going to solve for x here. So add x to both sides, you get 2x, subtract 7 from both sides. 7 minus 13 is 6. And when we solve for x, we get that x is equal to 3. And now we have to substitute 3 back in to find the measure of the sides. So 7 plus 3 is equal to 10. And if everything went accordingly, everything else should be 10. And if you go back and check, you'll see that it does. Okay, so this is a very, very, very important aspect of geometry, the triangle sum theorem. It's a pretty easy concept, and we've actually already mentioned it a couple of times in class. But basically what this is saying is that the sum of the measures of the angles of all triangles, any triangle you can think of, the sum of the angles, if I add up all 3 angles in the triangle, it will always equal 180 degrees, always. So now we have a little figure here, so every single triangle has to equal 180 degrees. So I have 2 triangles here, both of these have to equal 180 degrees when I add the 3 angles. And then it says solve for angle 1, 2, and 3. So we're going to start in this triangle because we have 2 angles here. So to solve for angle 1, we're going to do 180 minus 38 minus 67. And that gives us that measure of angle 1 here is 75 degrees. What hopefully we should notice here is that angle 1 and angle 2 are vertical angles. And that is a topic that we have been discussing since Unit 1, and I had mentioned it's one of the most important topics with geometry is knowing vertical angles. So if you need a refresher on that, make sure you understand what vertical angles look like. Vertical angles are always equal. So if this is 75, this has to be 75. Now we essentially have two angles in this triangle, and we can do 180 minus 48 minus 75 to figure out what angle 3 is. And angle 3 comes out to be 57 degrees. So that's the triangle sum theorem. All triangles, the angles add up to 180. These are corollaries. Corollaries means that it's things that we can pull from the theorem, like little fun facts that we can pull from the theorem. So it says the acute angles of a right triangle are, so in a right triangle, I have a 90-degree angle, and I know that this has to equal 180 degrees. So if I do 180 degrees minus 90, I'm left with these two angles. 180 minus 90 equals 90. So the two acute angles of the right triangle are complementary. So regardless of what these numbers are, they're always going to add up to equal 90 degrees, because 90 plus 90 equals 180. And then this one is saying that there can be, at most, only one obtuse or right angle in any triangle. So if you think about it, if I have a triangle, I can't have two right angles because that already equals 180 degrees, and what's the third angle going to equal? So that's a little fun fact. And then the last thing we're going to talk about here today is the exterior angle theorem. What the exterior angle theorem states is that the measure of an exterior angle of a triangle is the sum of the measures of the two remote interior angles. And essentially, according to this little diagram here, that would be the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. So to give you a little example of what this might look like using this figure, if I told you that this angle right here was 100 degrees, these two angles here are a linear pair. So if this is 100 degrees, then this angle right here has to be 80 degrees, because linear pairs add up to 180. So now pretend that if I just gave you this triangle instead, so like if I remove this part right here, if I kind of take that away, and I'm just left with this triangle, and I said, hey, this angle right here equals 80 degrees, what can you tell me about these two angles? Well, we know that the whole triangle has to equal 180, and if I already have an 80-degree angle in there, I'm left with 100 degrees to split between these two angles. I don't know what those two angles are, but I can at least tell you that when I add these two things together, it's going to equal 100 degrees. So that's what the exterior angle theorem states. So now down here, we're going to apply that to a problem. It says that we have a piece of quilt fabric in the shape of a right triangle, and we're asked to find the measure of angle ACD. So we're trying to figure out what the measure of this angle is here. So this is my exterior angle, so we can say that the exterior angle is equal to, and remember, it's the sum of the remote interiors. So these two angles here have to add up to equal this. So I can say x plus 90, because there's a little 90-degree angle box here. And now just solve for x. So this becomes 2x equals 80. X is equal to 40. And now to find the measure of this angle, we're going to do 3 times 40 plus 10. So that gives me 120 plus 10, which is 130 degrees. Alright, that is it on our first video. Thank you for watching.